I challenge you to watch this 10-minute long video. You will learn every single thing you need to create a real-life machine learning model. Ready? Alright, let's begin. Probability and statistics are essential for understanding and working with data in machine learning. This subject provides the foundation for many machine learning techniques and concepts, including probability distributions, statistical inference, and hypothesis testing. Probability is the branch of mathematics that deals with the measurement of uncertainty. It provides a framework for understanding randomness and modeling complex systems. In probability, we study the likelihood of certain events happening. We use concepts such as random variables, probability distributions, and probability density functions to model and describe random phenomena. There are two types of probability: classical probability and relative frequency probability. Classical probability is based on the notion of equally likely outcomes, while relatively frequency probability is based on a long-term relative frequency of an event. Statistics, on the other hand, is the branch of mathematics that deals with the collection, analysis, interpretation, presentation, and organization of data. It provides a framework for making inferences about populations based on samples. In statistics, we use concepts such as descriptive statistics, inferential statistics, estimation, and hypothesis testing to make sense of data. One of the most important concepts in statistics is descriptive statistics. This includes measures of central tendency, such as mean, median, and mode, and measures of dispersion, such as variance and standard deviation. These measures provide a quick and easy way to summarize a dataset and gain an understanding of its overall pattern. Inferential statistics is used to make generalizations about a population based on a sample. It includes estimation and hypothesis testing. Estimation is the process of finding the best estimate of a population parameter based on a sample. Hypothesis testing, on the other hand, is the process of testing a claim about a population based on a sample. In order to perform hypothesis testing, we must first specify the null hypothesis and alternative hypothesis. The null hypothesis is a default assumption that there is no difference between the population and the sample. The alternate hypothesis is the claim that we want to test. We then use the sample data to calculate a test statistic and a p-value. The p-value is the probability of obtaining a test statistic as extreme or more extreme than the one observed, assuming the null hypothesis is true. Probability and statistics are also used in machine learning to evaluate the performance of models. For instance, we use concepts such as accuracy, precision, recall, F1 score, and ROC-OC to evaluate the performance of a classifier. In conclusion, probability and statistics are essential for understanding and working with data in machine learning. They provide a framework for understanding randomness and modeling complex systems, as well as making inferences about populations based on samples. Understanding probability distributions, statistical inference, and hypothesis testing is critical for selecting the right algorithm and evaluating model performance. Python is the most commonly used programming language in machine learning. It is a high-level programming language that is easy to learn, versatile, and has a large ecosystem of libraries for data manipulation and visualization. Understanding Python programming and data manipulation/preprocessing is essential for creating and implementing machine learning models. Python programming is a fundamental skill for machine learning. It includes concepts such as variables, data types, loops, functions, and object-oriented programming. Familiarity with the syntax and semantics of the language is crucial for implementing algorithms and building models. Additionally, knowledge of popular Python libraries such as NumPy, Pandas, and matplotlib is also important. NumPy is a powerful library for numerical computing in Python. It provides support for multidimensional arrays, matrices, and mathematical functions. It is widely used in machine learning for data manipulation, linear algebra, and optimization. Pandas, on the other hand, is a library for data manipulation and analysis. It provides data structures and data analysis tools for handling and manipulating data in tabular form, such as data frames and series. Pandas is widely used for data cleaning, data wrangling, and feature engineering. Additionally, matplotlib is a library for data visualization. It provides functions for creating plots, histograms, and other types of visualizations. Matplotlib is useful for exploring data, visualizing the results of machine learning models, and presenting results. Data manipulation and preprocessing is an important step in machine learning. This includes handling missing values, scaling features, and transforming data. Data cleaning and data wrangling are the process of preparing data for analysis by removing or modifying observations that are incomplete, irrelevant, or duplicate. Feature engineering is the process of creating new features by transforming, combining, or selecting existing features. In conclusion, Python programming and data manipulation/preprocessing are essential skills for creating and implementing machine learning models. Understanding Python programming concepts and libraries such as NumPy, Pandas, and matplotlib is crucial for data manipulation and visualization. Knowledge of data cleaning, data wrangling, and feature engineering is also important for preparing data for analysis and creating new features. Model evaluation and optimization are crucial steps in the machine learning process. They involve assessing the performance of a model and making adjustments to improve its accuracy. Model evaluation involves using a set of metrics to evaluate the performance of a model on a given dataset. Common metrics used for classification tasks include accuracy, precision, recall, and F1 score. For regression tasks, common metrics include mean absolute error, mean squared error, and R-squared. These metrics provide a way to compare different models and select the best one for the task at hand. There are different optimization methods available, such as grid search, random search, and Bayesian optimization. Grid search, which is the simplest method, involves specifying a set of possible parameter values and training a model with each combination of parameter values. Random search, which is similar to grid search but less exhaustive, involves randomly sampling parameter values from a predefined distribution. Bayesian optimization uses Bayesian methods to model a function that maps from hyperparameters to the performance of the model. In summary, model evaluation and optimization is an iterative process where the performance of the model is evaluated using specific metrics, and the model is then modified using optimization techniques. If you made it all the way to the end of the video, I'd like to personally congratulate and thank you for your support. In future videos, we'll be applying these theoretical concepts into real machine learning models. Subscribe to join the journey. Thank you so much for watching. Peace out.